Can you what? Sure. No. No. All right, so here we go. If I give you, let's go with this statement. Let's go 3 to the negative 2, x to the 4th, y to negative 1 over 2 z cubed w to the negative 5th. Okay, and I want us to rewrite that. Okay, so rewrite it so that there are no exponents. So what are we going to do? Okay, so you're telling me to look at that first thing and determine if it's positive or negative for the exponent, right? So it's negative, so I need it to become positive, right? So you're saying put it on the bottom. Okay? So I'm now done with that one, right? My argument to you guys is go systematically. What I mean by that is develop a plan that you continue to use over and over and over again. And what I do is I look at first term, decide, does it stay or does it move? Go to second term, does it stay or does it move? Go to third term, does it stay or move? And as I start mixing those off, okay, when I eventually get to w to the negative 5th, and that's the last one, I know I'm done. Yes?
What's that middle number on the bottom?
3. Z to the 3rd. I'll erase it. Think better. Okay, so this x to the 4th. Does it stay or does it move? Stays. Why? Positive exponent. How about y to the negative 1st? Stay or move? Move. So it's going to become y to the 1st, right? So I'm done with the numerator. Let's go to the bottom. What do I do with that 2? Stays. What is the exponent that is with that 2 right now? 1. Okay, so it stays. What about the z? Stays. And the w moves. Okay. One thing that you can do, and I suggest that we probably do this. I do. We get, so the top is x to the 4th, w to the 5th. But what's 3 squared on the bottom? 9. And all these things are being multiplied together, right? So I've got a 2 in there as well somewhere, right? So what's 9 times 2 eventually? 18. So I'm just going to multiply my real numbers together and get 18. And then I have y and z cubed. Okay, that's usually what we would like to do instead of just leaving it as 3 squared y to the 1st, 2z cubed. 18y z cubed. It's simpler that way. Does that make sense? Seems like you guys got the hang of that, right? Feeling comfortable with that, okay? What if I had like, let's just say in this numerator I had like v to the 0. Where would that, or what would that have become? It would have become 1, okay? And I really didn't have to move it or anything like that, right? Anything raised to 0 power is 1. Okay, Lindsay?
So I probably had the homework about the statement to I was like that. But it's also use that like multiply. Like 3 is second like 9. Yeah.
So you had to expand it as 3 squared, as 9.
So like
yeah. And eventually, so after, section 7.2, 7.3, like that will become common practice, and you'll never really ever want to leave it as 3 squared. So it'll be something that we kind of build in and get used to. Okay, so I want to talk. Let's do this example first, because I think you maybe see some of these. It's just getting us to substitute once we rewrite an expression that has negative exponents, then substitute specific values for those variables. So we're starting here with 3s cubed, 3s cubed t to the negative 2. I want to rewrite that, okay? It's not a fraction, but what can I put that all over? 1, okay? And the reason I like to do that is because it helps me realize that there is a numerator and denominator here, okay? So what's the exponent that goes with that 3? 1, so is it going to stay or move? Stays. What about the x cubed? Stays. What about t to the negative 2? Moves, right? Is that okay with everybody? So my suggestion is to do that first. Okay? Rewrite your, if it's got negative exponents in it, rewrite it so that they're all positive, and now substitute. Okay? So they tell me s is 2, right? Just remember when we substitute, I'm removing the s, and I'm going to replace it with 2. But I'm going to replace it, I think it makes most sense to replace it with those parentheses. Okay? And you're going to find out why we need to do that here in the bottom. Okay? It's not a huge deal when I am going to raise a positive number to any exponent. But it does become a huge deal when I raise a negative number to an exponent. Okay? Because remember, exponents refer to multiplying, right? Or repeated multiplication. If I have an even number of negative numbers multiplied together, what kind of answer does that give me? A negative times a negative is a positive. And so a negative times a negative times a negative times a negative, if you had 4 of them, what's that going to give you? Positive as well. Okay? So that idea is going to help me realize what kind of number I should get here with negative 3 being multiplied by itself 2 times. If I don't put those parentheses around that negative 3, I don't square the negative. Does that make sense? And I would have a negative result, but I should, at the end of this problem, have a positive result. Okay? So when you substitute, especially when there's exponents, make that substitution with parentheses. Okay? So now let's evaluate this. What is, order of operations? If you remember, parentheses have to be done first, and with fractions, we talked about the division bar kind of being a grouping thing, saying that those are separate sets of parentheses, essentially. So I look at just the numerator, just the green stuff, and now I run through order of operations again. So I get to exponents, right? So I got to do that first. I got to get 2 cubed. What's 2 cubed? 8. Okay? So this thing is going to return to 3 times 8. And what's the bottom going to turn into? 9. Okay? Now, at this stage, you've got options. Okay? What do you guys want to do? You want to multiply that out, or do you want to cancel like terms right now? Multiply. So what's 3 times 8? 24. And then we got a 9, right? Now, they're going to ask you always to simplify these. So is there a number, is there a common factor that is shared with 24 and 9? And you said what? 3. So 3 will divide 24 8 times. And it will divide 9 3 times, right? I personally, and I'm not saying you have to do this, but I personally like to do that here. I see that the 3 and the 9 have that common factor right away of a 3. I cancel them. Doesn't that leave me with 8 over 3 right away? My thought is if I'm going to have to reduce and simplify, but I've got a process of multiplication to take place first, kind of think about multiplication and division undo each other, right? I don't think it makes a whole lot of sense efficient-wise to multiply and then the next step essentially undo that multiplication again to some degree. So I like to cancel before I actually do the multiplication, but it's up to you. It doesn't matter. Okay? You guys feel comfortable being able to do that? And some of you said that you've looked at the homework and you felt comfortable doing the homework, so that's good. I'd like to get into some other ideas here that I'm not necessarily going to quiz you over or test you over, but I think they're facts that are pretty important for us to understand. Hunter.
Where did you get the 8? Oh, never mind.
Sure?
Yeah.
Okay, all right. So the next couple things, you've been taught in your math careers that you're never allowed to divide anything by 0. Okay? I want to talk about why. Okay? Another thing that we talked about yesterday was that anything raised to the 0 power is 1, except for we got to 0 raised to 0 power, and then our technologies had different results. One said that it was undefined, the other one said it was 1. Okay? So I want to talk about these two ideas, division by 0 and raising 0 to the 0 power, and talk about how maybe looking at patterns and relationships, we can kind of judge and maybe determine a reason why we can't do these things. Okay? So the first thing I want to do is actually the one raising 0 to the 0. So here in yellow is what I actually am going to try to answer. Okay? What is 0 raised to the 0? Okay? And here is the argument. Now I'm starting with 3, 2, and 1 as my basis. But I could have started with 4, 5, 6. But I want to get all the way down. You see at these bases, I'm just going to highlight the bases. 3, 2, 1, and then it gets to 0, right? Is there a pattern there? 3, 2, 1, 0, right? I'm decreasing those bases by 1 each time. Does the exponent stay 0 each one of those? Yeah. There's a little bit of pattern there in the way I set this up, right? So my hope is if we see a pattern there, when we evaluate each of these, maybe we see a pattern that can allow us to make a conclusion. So from what we talked about yesterday, what is 3 to the 0? 1. What is 2 to the 0? 1. What is 1 to the 0? 1. Okay? So we've established a pattern with that blue stuff, right? 3, 2, 1, and down to the 0. But each one of those equated to 1. So what do you think, based on that pattern, what should we argue that 0 to the 0 is?
It's 1 by
1. Okay, let's just put 1 here.
Okay.
So we get 1 there. So using this is called inductive reasoning. By looking at it's coming up with a conclusion using patterns. Okay? We get that 0 to 0 we think should be 1 because of that pattern. Okay, look at the next column. 0 to the third, 0 squared, 0 to the first. So now I'm keeping my bases all 0, but now I'm changing my exponents, right? Let my exponents decrease. Does that pattern eventually still get me down to 0 raised to 0 like the first column did? Yeah. Okay, so what do you think 0 to the third is? If I take 0 times 0 times 0, what do you get? 0. What do you get if you take 0 times 0? 0. Okay, what do you get if you take 0 to the first power? 0. Okay, so we've established a pattern based on the left-hand side of these equations, and each one of these is giving me 0 as a result, right? So what do you think you should get based on that pattern? What do you think you should get right here? You think you should get 0. Do you see then that there is a pattern that establishes that 0 to the 0 is 1, and there's a pattern that establishes that 0 to the 0 should equal 0? Okay, well, do you know any numbers that hold 2 values? Like, say, is 5 ever exactly the same? If you have 5 apples, is that ever the same as saying you have 7 apples?
How did I know you were going to say 7? I'm a psychic.
Okay, what am I thinking now?
Psychic.
Oh, okay. 0 to the 0 equals 1, 0 to the 0 equals 0. That is saying that you have now identified one value, 0 to 0, being labeled as 2 amounts. And that never happens. That contradicts all the math that we currently know. 5 is 5, 6 is 6, 7 is 7. Okay? 0 has to be 0. It can't be 1. Does that make sense? All right. So that is our argument of, at least right now, with the math skills that we have and the knowledge about math that we have, that is our best argument for saying why we say in this class 0 to the 0 is undefined. Okay? We can't make the correct decision.
What did you think that 3 to the 0 would be 0?
3 to the 0?
I think 3. I'm at 3.
3 to the 0 be 3?
Why did you think that since you're not doing anything with it? It's 3.
We will revisit this
That's stupid.
in 2 or 3 sections. Because I agree with you that that's kind of silly to think that. Because you have to basically do this pattern, you have to be in agreement with me that 3 to the 0 is defined to be 1, right?
Yeah,
but in 2 sections, we will actually see how we get 3 to the 0 to be 1. And we'll come back to this and do it again. And that'll make more sense.
Did they do this when I was in school? With
Just algebra. Algebra 1.
This is algebra 1?
Mm-hmm.
I don't remember doing this in algebra 1. What is this, 3?
Exponent.
I don't remember this. Like, I don't remember this. Of course, that was a long time ago.
So that is our reason why we, in this class, are going to say 0 to the 0 is undefined. We don't have a number for it, okay? Now let's talk about division by 0, okay? And I'm going to show you two different routes here of why we cannot divide by 0, okay? Two different proofs, okay? Take your calculators out real quick, or just something, calculator, computer, whatever, something you can do this division for me with. If it's your phone, that's okay.
Oh. You can use your phone? I want to see if I have a calculator on my flip phone. Can I?
No. Because you don't.
Really? I don't?
You probably do.
Calculator. Ha!
Ha!
I don't know how to work it, though, to be honest.
What is 1 divided by 0.1?
Wait, let me do it real quick.
10.
That's Brady.
Okay.
10.
What the
So you're taking, that's 10, so you're taking, think about this, you're taking 1, the distance from 0 to 1, and you're going to divide it by 1/10, which means break it up into 10 sections. Does that make sense? And then the question is, well, how many sections would you have then? You'd have 10, right? So 1 divided by 0.01 is 100. Okay. Next one's 1,000. Okay, good.
Do you guys know something after a million? I know.
10 million.
Oh.
100 million.
Duh.
A billion. Okay, 10 billion, 100 billion. Trillion. Okay. Okay. So kind of arguing the idea, what if I put, what are you recognizing these numbers are doing here, these quotients are doing? Yeah, they're going up, right? And they're going up dramatically, yes? So if I were to add like another column or another cell here that says 1 divided by, let's go, 0.0000000000000000001, that would be a 1 with a bunch of zeros behind it, right? And it would be much greater than a million, correct? You guys understand that? Okay. What are these numbers? So you're making the argument that these numbers keep getting bigger and bigger and bigger, right? What are these numbers here doing? Just the ones that I highlight. Okay, so I'm adding a 0 before a 1 each time, right? Okay. So are those numbers getting smaller or are they getting bigger? They're getting smaller. I should kind of give you a visual here real quick. What's going on there with those blue numbers is right now I've got this point located at C, right? Okay. C is, and this is the number of 1. So this is going to demonstrate those denominators. Those denominators right now at 0.1, we would be that close to, this red line is 0, right? Okay, at 0.1, we would be right there. Now at 0.01, what we're really going to do is we're going to divide this little region here into 10 segments and find 0.01. So 0.01 is going to be right there. Does that make sense? Okay. Now, let's see, where did that number go? There it is. Okay. So there's my 0.01. Now if I go 0.001, see if I can get there. Close enough, okay. So I'm going to zoom back out. So now, let's go rounding. Okay, so that's close to 0.001, right? Okay. But what is that point C doing? It's getting closer and closer to what number? 0. Okay, so here's my question. We are, with this right here, these numbers in blue are getting closer and closer to 0, right? Does that make sense? So if I were to continue this, eventually I might be at like 1 divided by 0. But when that pattern happens, what are we seeing is happening in this green stuff? What are those numbers getting closer and closer to? Okay, so what's, okay. So I'm looking at, you said bagajillion, okay? I don't think it is. Okay, so this is getting very, very large, right? So maybe we say infinity. Well, let's just go with that, okay? Everybody okay with that?
Yeah.
So that's working on the right-hand side of 0. Look at the stuff on the right over here, okay? Is this really the same thing? Okay, so what is 1 divided by negative 0.1? Negative 10. This will be negative 100, right? Negative 1,000. Okay, so negative 10,000. Yep, negative 100,000. And this would be negative 1 million, right? Okay, so that argument is this image where we start over here, and now as we progress through that list of division, I'm dividing by numbers that are closer and closer to 0 from the left-hand side, right? Okay. So as these numbers, so these, I'll highlight them again. Let's see. These blue numbers are getting closer and closer to 0, aren't they? Does that make sense? Are we good with that? Okay. But what are these numbers over here getting closer and closer to? Negative infinity, aren't they? Does that make sense? So think about this. Did we just show that on the left-hand side, using patterns, on the left-hand side, 1 divided by 0 should be infinity? And if that's true, then I should say every single time that I say 1 divided by 0, you should be able to tell me that the answer is infinity. But the column on the right says 1 divided by 0, there is negative infinity. So we can't define that amount, 1 divided by 0, because we don't know if it's infinity or we don't know if it's negative infinity. Does that kind of make sense? Okay. So that's one reason we don't divide by 0. Okay. Here's another reason, which I think is maybe a little bit more obvious. Give me an even number.
I like 2.
I said 4. I said 4 first.
Let's go 28. Let's go 28. Okay. And I'm gonna set 4, so let's divide by 4. Okay. So I do that, or if I write it this way. Okay. When I ask you to take 28 divided by 4, that is ultimately a request for what number do I take 4 and multiply it by to get 28? 7. Okay. So when we say 28 divided by 4 equals 7, that means 4 times some number 7 should give me 28, right? Does that make sense? Okay. Here's my question then to you. If I'm going to take 5 and divide it by 0, I should get some number back like 7, right? I'm just going to call it n for now. Okay? So let me just do this real quick. Let's go back. So we understand this idea with the 28 divided by 4 equals 7, right? Let's say I take 28 divided by 4, and that gives me 7. But now I'm going to call that 7n. Okay? So let's say that we didn't know what it was. But doesn't that mean that n times 4 should equal 28? Does that make sense? Is that okay with everybody? So doesn't this mean then, if that pattern there makes sense, then isn't this a request that says n times 0 should equal 5? Does that make sense? So when I say 5 divided by 0 equals n, I'm telling you that is going to be a request for some number n that when I multiply it by 0, I get 5. That doesn't make any sense, right? N times 0 is what? N times 0 is 0. So this side here would be 0. Okay, this would be 5. That is what we call a contra. That's a symbol we use. It's like a sideways hashtag. It's a contradiction for what we know. It goes against all the math that we understand, right? Contradiction. Okay? There is no number that when you divide by 0, that you get that quotient back, you can multiply by 0 to get the numerator, essentially. That kind of makes sense to everybody? So that's why you cannot divide by 0, okay? Now, going a little bit further, people always ask, well, what about this? Because we know that 3 over 3 is equal to what? 1. 5 over 5 is equal to what? 1. 15 over 15 is what? 11 15 over 11 15 is what? 1. 0 over 0 then.
2? What?
Using the pattern that you've developed here is that we got the same thing divided by the same thing, and we always want to argue that that's always 1, right? But we've got some things going on here. That means, well, hold on. That means that 0 divided by 0 should give me some number. Is it 1? Is it 0? Is it 5? Whatever. Who cares? Think about this. Doesn't that mean that n times that number 0 should give me that 0? Does that make sense? And would you agree with that? Is n times 0 equal 0? Hold on. Does n times 0 equal 0? Okay. So remember what n is. N was the quotient that we got from 0 divided by 0. Could n be 1 here? 1 times 0 equals 0, right? Could n be 2? Could n be 3? So the argument is when I take 0 divided by 0, I don't know what that is. It could be 0, could be 1, could be 2, could be 3, could be 4. So it's what we call indeterminate. You can't make a judgment. Indeterminate. To determine something, right? If I've made a determination, let's say that, how old are you, Jaden? I have determined that Jaden is 15. That's a fact, right? The determination. If his age was indeterminate, let's say he didn't know when he was born, he would not know his age, right? Okay? Maybe have to be a ballpark idea, but when we don't know something, kind of like undefined, a synonym for undefined is indeterminate. Okay? So does that kind of help you see, like, all these facts that you guys have been told throughout your years? Can't divide by 0, 0 divided by 0 is undefined, that kind of stuff. There's logic why. There's reason why. Okay? Hopefully that sheds a little light on those reasons. Okay? You guys have any questions about anything? Tree? What's tree mean? Is that the sign language for tree? All right.
Hey, you are ugly.
Burrito.
This is cat. Meow meow.
Burrito in Spanish means little donkey.
It does?
Oh, yeah?
Wait, what?
Burrito in Spanish means little donkey?
I thought you were telling us what you called it donkey.
No.
Oh. I don't get it. Dog is big dead.